Hey guys. Thank you. All right, let me see if I can work this thing. Yeah, so today we'll be talking about building cost visibility for your Kubernetes cluster. So first, a little background on where this information is coming from, who I am. Let's go one more. Yeah, so I have over 10 years of experience with DevOps, infrastructure, automation, cloud scaling, data centers. And in the last couple of years, I've been helping a bunch of companies go through the process of getting onto Kubernetes, containerization, into this whole new software development lifecycle of building and deploying CI/CD and automation. So with that, I also work for Managed Kube, and a little bit of background there is that we also create development tools. The first one is a Slack bot that helps get your Kubernetes information into Slack to give you more visibility and easy-click interface. So that saves you time, gives you information, and it brings that information into Slack. But so today, we'll be going through the importance of cost visibility. How do you do that? How do you measure it? Then a little bit talk about what the tools are out there right now to get these kind of metrics and dashboarding available to you. Then we'll talk about a little bit about how these tools work. And then finally, with this metrics in mind, how do you use it to cut costs and move forward? So first, why Kubernetes? Kubernetes is an orchestration system. So if you're running a lot of containers, you'll want to use some kind of orchestration system to help you manage these containers in a easy-to-use fashion. So Kubernetes is a very nice way to go about that. So the importance of cost visibility. What does cost visibility get you? And who cares about these metrics? So the first thing you want to know is who's going to consume these metrics. And there are a few consumers that I've found working with these companies is that there's the management types, DevOps types, and then the developer types. Right? The management types usually cares about the entire cluster costs, and then the cost of a namespace. And then in Kubernetes, the namespaces usually break out into things like application, groups, so it aligns very well on that axis. And then you have the DevOps folks where they're kind of interested in all of the above, but in a kind of service way just to see if there are any outliers or outsized costs in the infrastructure so that they can help improve or point problems out. Then there are developers. The developer types are more interested in really just their application, right? Like they're not interested in the cluster costs. They're interested in how much their application costs or segments of their application as in microservices. And so with this information, you can do a lot of things. So you can forecast and plan, optimize your cluster, and then understand product margins and how your application and how much your application costs. But to build cost visibility, these costs that are coming out of your Kubernetes cluster is not apparent with your cloud cost bill. So if you're in the cloud on GCP or AWS, you don't get the breakdown on the Kubernetes level of what your POP are costing you. So for example, here's an example of a chart that AWS gives you. So it's very nice, right? Like it breaks down and it slices and dices everything from what they're actually charging you. EC2 instances, network charges, ELBs, RDS, or whatever. Every single thing that they're actually charging you for. But however, if you're running Kubernetes, it doesn't show you the container costs of it. The reason why is that usually the cloud providers don't know you're running this thing called Kubernetes. And even if they did, they're not charging you for this Kubernetes thing and charging you for the pods that you're running on there, right? They're charging you for the instances that they're providing you. So with that, you need tools that has Kubernetes and is aware of Kubernetes that's there and it's getting information from Kubernetes. So let's talk about some of the tools. And let's go over some of the commercial tools first, briefly. So there's a tool called Cloud Health. It has an agent that lives in your cluster. It talks to your Kubernetes API. It gets the pod information, and it calculates the CPU and memory usage so that it'll get the pod cost, it'll bubble that up into namespace costs, and ultimately bubbles that up into cluster costs. And if you have multiple cluster, you can bubble all that up into multiple cluster, and then so you can slice and dice it from there. Another commercial tool is called Cloudability. Same thing there. It gives you practically the same type of information. But however, these tools cost a fair bit of money. It's usually 1% to 3% of your cloud bill per month, depending on what rates you're able to negotiate with them. Then earlier I said that cloud usually never gives you this information, but that's not totally true. So like GKE has this thing called GKE usage metering, which is a dashboard that consumes the information from your Kubernetes cluster and slice and dice it on the same kind of information on the pod. It aggregates up to a namespace, and it aggregates up to cluster. However, these tools, this tool in particular, doesn't integrate back with your cloud billing. So it's it's a side tool that you have to set up. And really, GKE is also not charging you for Kubernetes. They're really charging you for instances. So those are usually not available in your bill. Then there are open source tools. And this is a Grafana dashboard from Carl Stoney. It's a very good dashboard. It gets you exactly the same information. It uses Prometheus, kube state metrics to gather this information. And it gives you pod cost, namespace, and cluster costs. And then it also allows you to enter in your cost assumptions, how much you're paying for CPU, memory on your cloud. And if you have any discounts that is available to you on the cloud, you can also enter in those assumptions in there also. Another tool is a kube state report. So this tool do not use any third-party resources like Prometheus or kube state metrics. It's all built in. It talks to the Kubernetes API directly and gets this information itself, and then it calculates the same type of costs and gives you the dashboarding available to it. Then there's another really good tool called CoreOS Metering Operator. It's more enterprise-like. There's no dashboarding available to you. But usually, if you would want to integrate this with your own enterprise dashboarding tools, like Tableau or what have you, this is a very good tool to create these pipelines to give you cost visibility. And then here's a chart that kind of goes through these tools and kind of breaks down on what they give you. Some are easier to use, some are harder to use, some are a little bit more involved. And so it's a nice breakdown here. So with that, we'll take a look about how these tools work. Oops. So the first thing you'll probably do is install one of these tools, go to a dashboard, and get the cluster costs. And then you're going to go to your cloud billing and try to match that up. And what you're going to find out very fast is that these numbers don't match up. So, and you're going to be like, why? Why don't these numbers match up? There's something wrong with these tools. But to understand that cost, we'll look at a little bit about how these tools work. Oops, can you go back? Thank you. So these tools mainly work by gathering information from Kubernetes. So for example, like Prometheus, or if it goes directly to the Kubernetes API, it gets the CPU and memory requests and limits, and from there, it starts calculating the costs. So what are these CPU requests and limits? These are configurations on your pods that request CPU, number of cores, or memory that associated with this pod, and it must be met before Kubernetes schedule these pods onto a node. So that makes it a very good metrics to calculate costs on, right? But however, these numbers usually don't fully add up. If you want to over-provision your node, you might set these to a little lower number. And a lot of times people are a little overzealous about these numbers, and they set it to not the right settings, so the calculations are a little off. So if we look at one of these tools, for example, Kube resource report, we can see that it's taking the request CPU and multiplying that by the cost per CPU and doing the same thing for memory to get the total cost. So with that, it takes these metrics, gives you a number, but these numbers are usually user settable, so it might not equate to what the exact node is doing, right? Because the node is also using resources to run Kubernetes. Kubelet that sits on the node is using resources, and if you're not accounting for every single thing, you're missing pieces of the pie to be accounted for. So since we're looking at Kube resource report, it also has an interesting metric called slack cost. So the slack cost is a calculation of what the pod requested minus the actual usage. So this is really the waste, right? So let's say I requested 4 CPUs, and the actual usage is actually 2. That would mean that I'm wasting 2 CPUs there that are kind of just sitting there idle. And Kube resource report kind of tells you this. Next. Thank you. So you might be asking, what do these tools kind of give us? It gives us a number that can be very close to what the cloud provider is actually charging us. It might not be exact, but it also gives us a number where we can compare across the board from pod to pod, namespace to namespace, application to application. So it gives us kind of a baseline number to be able to compare apples to apples with these cost analysis. So with these numbers and metrics, so now we can quantify what our cost is. We can talk about how we can cut costs, and then once we implement cost cut tactics, we can then remeasure the cost and see if we're making improvements, or if we're not making improvements, it's going up or down. So with Kubernetes, there's a bunch of cost-cutting tactics, such as like the cluster autoscaler, namespace quotas, horizontal pod autoscalers, and things like that. And we'll talk briefly a little bit about each one of these. So the cluster autoscaler helps you scale up and down nodes when you need it. So for example, if you look at the picture here, you have pods that are sitting in pending state. It could be in pending state for any number of reasons, but these pods are in a pending state because it's waiting for some resource. And here is saying, well, I can't actually read it, but here is saying this one in particular, I believe, is waiting for a CPU resource that's not there. It has not enough CPU resource on the cluster. So what the cluster autoscaler does is it detects these events, and it will go to your cloud and turn on more nodes that's able to fit this pod onto. And then on the flip side, it will also do it on the reverse, right? Like, so when you have scaled down and this pod is no longer there, the cloud provider, this cluster autoscaler will delete this node and scale your node count down. So this will help you automatically manage your node counts in your fleet of Kubernetes node. Then there's namespace quotas. So this is not exactly a cost-cutting tactic. However, it can limit runaway automation. So if, for example, if a developer says, hey, instead of saying I want 10 copies of this thing, and they accidentally punch in an additional 0 and say, hey, I want 100 copies of this thing, with node autoscaler turned on, this might scale your cluster out, to a really large size. But however, you place namespace quotas onto a namespace where your developers have control of, and give it a limit, then it'll go up to this limit and it's not going to go any further. It'll give errors saying you can't do this. So it'll limit how much resources that an application can possibly take. Thanks. And then there's also a horizontal pod autoscaler. So if you guys are familiar with like AWS autoscaling groups and scaling by like a CloudWatch type metrics, this is kind of the same thing, but on a Kubernetes level. So the simplest form is that you can scale on CPU usage. When CPU usage goes over X, when aggregate CPU usage of this pod goes over X, it would start scaling this pod up until the aggregate CPU level is at a certain point. And then on the flip side, it'll do the same on the way down if it's below. So it'll help you scale up and down your pods when demand is needed. And you can also do this with custom metrics. And if you're on AWS, you can use stuff like spot instances, which are typically very discounted. But however, you do have to be careful on using these instances because it can be taken away at any time when the demand is there for these spot instances. So your application do need to be able to be aware of this, and your application needs to be able to sustain these nodes being taken away at any time. So failure is, handling failures is very important. And then also, if you're on AWS, there's reserved instances. These are instances where you can put upfront money or sometimes no upfront money and get a very discounted deals on the cost per hours. So it saves you money by locking yourself in a little bit on what your usage will be on AWS. So yeah, so in summary, understanding cloud cost is important. Pretty much every single production deployment I've done, eventually someone's going to ask, how much is this stuff costing me? And in the beginning, I was like, I don't know. You look at your node costs, but people keep on demanding these answers, and going through this, there's a lot of solutions out there, open source solutions if you don't want to go with commercial products, to get you these numbers so that you can quantify the cost of your pods that are running your Kubernetes cluster, and then do iterations on that to either cut costs or shift applications to different lines so that it lines up to your budget and forecast. And yep, so that's it. Yeah, so feel free to email me with any questions or any conversations that you have. I'm happy to help. And here's a link of all the tools and open source things that I've kind of mentioned in this talk. Thank you.